I'm going to spend a little time. So I'm going to start by just introducing myself and our company. And then I'm going to spend most of the talk sharing a little bit about just big developments I've seen in AI over the past 10-ish years. Actually, I'm curious, how many people here have been, are like new to AI? I don't need, how many of you here are even working in AI? Can you just raise your hand? Okay, most people. How many of you have been working in AI for over, say, 2 years? What about over 5 years? Okay, so is it still quite a few people? Awesome. So to introduce myself, I'm Robert. I started doing a PhD in machine learning in 2013, UC Berkeley. And originally I was working on research in reinforcement learning, deep learning training, algorithms for learning from data, optimization algorithms, more on the algorithm and theory side of things. But the interesting thing was, at least for myself, even though I was trying to work on the algorithms, I found that I was spending all of my time managing clusters and shuffling data and getting engineering things to work on spot instances to be cheaper, things like that. And so I was spending all of my time on the systems and infrastructure challenges for doing AI. And so in 2016, Philip and Jan and myself started Ray, which is an open source project, basically trying to solve some of these systems challenges around AI, basically to make it easier to do distributed computing for AI. Because we thought, hey, AI is super computationally intensive, right? It's becoming more and more computationally intensive. You need to scale things. That introduces a lot of hard systems challenges. And so let's build some useful open source tools to try to address some of those challenges. And 2019, we started Anyscale to try to commercialize Ray and to continue developing Ray. OK, so this is a picture of us from back working on the open source project back at Berkeley. And really, we started it, this was actually 2016. Not a lot of people, it felt like AI was really taking off at the time, that AI, everyone was thinking about AI ever since 2012, 2013 with ImageNet and so forth. But when we started the company and started pitching Ray, distributed computing for AI to people, initially it really was not landing. Partly because most companies were not thinking about AI. And if they were thinking about AI, they really weren't thinking about distributed computing for AI, except for some of the biggest companies or the earliest adopters. And so the real inflection point for us in terms of Ray adoption, so when we started the company in 2019, we really just had one Ray user, one production. There were a bunch of people trying it out, but we had one serious production Ray user, which is a Chinese company called Ant Group, or Ant Financial. They make Alipay, which is an app for paying for things in China. And today they actually run a third of their compute on Ray. So they're still a big Ray user. This is everything from large GPU clusters for serving models to online learning to graph and stream processing, things like that. But back in 2019-ish, they were pretty much the one serious production Ray user. And the inflection point for Ray was ChatGPT, when everyone started caring about AI and the need for scale became far more obvious, right? The need for bigger models, more data, more compute. For people started talking about scaling laws, right? The idea that if you train bigger models with more data and more compute, you can just get better results. So now we talk to these companies. These are all companies using Ray. We talk to these types of companies, to the people leading ML platform teams and stuff like that. And a lot of them tell us that their top priority on the infrastructure side is just enable training with way more data. And because, because you have this formula with the scaling laws to get better results if you can train bigger models with more data. And they're all trying to enable training with more data. But if you try to enable, training with 10 times or 100 times more data, there's a good chance you're going to break all of your systems, because you just didn't design that far in advance. And so a lot of these infra systems people are finding themselves kind of on the critical path to really deliver these better models and new results. So I want to just give you a couple examples of the types of use cases that we work with. This is one of our customers is a company called Runway. They do video generation models. And you can imagine, compared with the types of use cases we were seeing a few years ago, what does it take to build a model like this? Well, first of all, you have a ton of video data, right? And this is a a meetup about like multimodal data and everything like that. Video data is incredibly multimodal, right? Of course, there's video, you've got audio, there could be text and inside of the videos. There's metadata associated with the videos. And you're not just training a model, you're like, in order to train the model, you're not just training it on like raw video data. You're often really, the quality of the data matters a lot. So you're really curating the data and like potentially generating synthetic data, right? Like filtering out low quality data, or taking the raw videos and generating text descriptions, things like that. So you're actually running a lot of inference and using a lot of AI in your data processing. And the other example I want to give, just because it's like the totally other end of the spectrum, this is a blog post Amazon wrote about using Ray, switching to using Ray for one of their data processing workloads. And this is, the exciting thing here is just the scale. It's an exabyte scale data processing workload, which is huge. And if you read further down in the blog post, they say that by switching to using Ray, they're saving over $100 million every year. So that's like, I think, very exciting, and just a totally different type of use case. Okay, so that's a little bit about what we're building. Ray is the open source project, Anyscale is the company. And now I want to talk a little bit about some of the developments in AI over the past few years. So I've been working in, or thinking about AI since roughly 2012, 2013. And, of course, year to year, for a while, it felt like, you don't see such massive changes, but looking back, there have been so many things that have changed. And I want to call out a few specific developments that I think are some of the big changes in the way we think about AI. So first of all, how many of you have heard of the ImageNet dataset? Can you raise your hand? Okay, so quite a few people. This is a pretty famous benchmark in computer vision. And this benchmark drove most of the progress in AI and computer vision, over the last, decade or so. And this was the benchmark that deep learning first did really well on. So the Toronto team showed that you can use convolutional neural networks to just like blow all the other methodologies out of the water on this object recognition benchmark. It's like millions of images split into your training set and your test set. You like train the ConvNet on the training set, and then you evaluate it on the test set. And they did way better than anyone else. And so ever since then, 2012, 2013, deep learning has just like taken off. Now, and then every year, people would compete to like come up with a better model that got a higher score on this benchmark. And the way that the whole field thought about this benchmark was that the data was static, right? It's like the ImageNet data set, your training data, test data, and all of the research and innovation goes into like coming up with a better model architecture, coming up with a better optimization algorithm, and then running that on your training data and then evaluating it on your test data. And now, now the way we think about things is a little bit flipped. It's like almost the opposite, where the model architectures are a little more static. The way people optimize the models and learn is a little more static. And the thing you actually put all of your effort into is the data. Like the data, instead of being a static data set, the data is like the variable that you optimize over to really get a better model. And that is, it's a big shift, and it's just like kind of a fundamental shift in how people think about it. So that's been one interesting transition to see. And so, by the way, you also probably see a lot of headlines saying that, pre-training or scaling laws are like ending, they're reaching their limits. One thing that may be true is if you've trained on all the data on the internet, like these foundation models, then, or half the data on the internet, then there's going to be diminishing marginal returns to, training on the last 50%. Or if your model has seen, 100 million or 1 million Yelp reviews, like, are you going to learn a lot by reading another 1 million Yelp reviews? Like, maybe not so much. But these models will continue to get way, way better. It's just that the path to making these models smarter is not going to be by scraping more data from the internet and just getting more of the same data. The path to making the models smarter is going to be to get higher quality data. And I think the path to getting higher quality data is going to be to actually put more compute into making the data better. So this could be like using AI to generate synthetic data, using AI to filter out like high quality data. But generally, I think you're going to, instead of just turning more raw data into better models, you're going to turn more raw compute into better data and then into better models. The second thing I'm going to talk about is unsupervised learning. So how many of you have taken an intro machine learning class at some point? Okay, cool. You may have seen does this look familiar at all? Have you seen some figure like this? So first day of your machine learning class, they tell you machine learning, there's like 3 parts. There's supervised learning, unsupervised learning, and reinforcement learning. And supervised learning, like we understand it, this is like you have X and you want to predict Y, right? You have XY pairs and you get labeled data. And you can fit a model to them, like regression or classification, or like you can use a neural net, you can use a support vector machine, you can use a decision tree, whatever it is. Like we have theories about this, like we know how to do it. And there's a bunch of algorithms. And then they'll say unsupervised learning, like we don't really know how to do unsupervised learning. This is learning, you have unlabeled data. Like there's lots of raw text out there, lots of raw video out there. Like intuitively we should be able to learn from this, but we don't really know how. And then they would say something about k-means clustering and stuff like that. And then lastly, they would say, okay, reinforcement learning, that's like some other thing. And decisions and sequences and so forth. So I think the big development here, and they were right, like we didn't really know how to do unsupervised learning. But I think one of the biggest changes over the past decade or like breakthroughs in AI is I think now we do know how to do unsupervised learning. And the answer is basically, it's basically what pre-training is. You take your unlabeled data and you turn it into a lot of supervised learning problems. Like you basically make a lot of small prediction problems out of your all your unlabeled data. Like you take the first part of the sentence and then predict the next word. That's a supervised learning problem. And you can generate an unlimited amount of these types of problems from your unlabeled data. And then you learn a model that can do that, and then hopefully the model can be adapted easily for other downstream tasks. So that is, I would say, at least a good answer now, the best answer we have now for how to do unsupervised learning. So I think that's like, looking back at the time scale of maybe like 10 years is a really huge amount of progress. Yeah. The last thing I want to say is a little bit more sort of like business oriented, and this is that multimodal and unstructured data is really going to be dominant going forward. So if you are in a company, there's some amount of data you have in your company that is nicely structured, like in a database. And you can query that data, you can ask questions, you can run your SQL queries, and that's the main way companies get insights out of their data today, right? The reason companies have all this data, the main reason, one of the reasons, is that they want to use the data to get insights or like learn stuff or draw conclusions. And to do that, you have to be able to ask questions to your data. And right now you can do that if your data is nicely structured and tabular and stuff like that. But most data is not in that nice kind of format. And I think the Box CEO, Aaron Levy, had a really nice tweet, which I will share and actually read. So he said, the vast majority of an enterprise's data is unstructured. Think about contracts, financial documents, digital assets, movie scripts, product specs, HR docs, right? It's really important stuff. And he's saying that, like, for all our structured data that lives inside a database, you can query it easily, get insights. But for all of your unstructured data, just think about if you're recording this presentation, right, like that's some unstructured data that'll live in your Google Drive or whatever. Like making use of it has been nearly impossible. And in fact, the more of it you have, sometimes the harder it is to work with and the less valuable it becomes. And with AI, this is reversed, right? He's saying, what if you could ask any question you want, right? Automate any workflow instantly. What's our best performing product line? How many contracts have risky terms in them? Which clients do we have promotional rights to? Show me all my open invoices. All of a sudden, the more information we have, the more valuable it becomes. And we can innovate more and accelerate progress. So think about, like in your company, what fraction of meetings, like how many of your companies record all of the meetings? So almost nobody, right? You record some meetings. And the reason you don't record all the meetings is that no one's going to go back and watch it. So it's not really, you don't actually get value out of recording it. And that's true, you don't go back and watch it. But in the future, AI will go back and watch it. And there's going to be some new employee who's onboarding who wants to know, oh, why was this decision made? Or why was some product decision designed this way? And there's going to be some AI agent or product or whatever that will go retrieve a bunch of data, meeting recordings, design docs, Slack conversations, and read the stuff and reason about it and maybe retrieve more stuff and ultimately try to get an answer to that question. And we're going to start to get value out of all of this data. And once people see that they're getting value out of all this data, they're going to, everyone's going to start recording way more of this data because it's actually useful. And so the amount of data of this type is just going to be, growing way more than it is today. And it'll, even in my personal life, I've started just taking more pictures and videos and things like that. Not because I don't look at any of them, but I just assume they'll be useful. Some AI thing in the future will look at them and retrieve them at the appropriate times and make them useful. So I think that's true in your personal life as well as in a business context. I've been taking a lot more voice notes in my personal life as well, just because it's faster than typing, and because I assume I'll be able to retrieve it later when relevant. So I so far have not made use of any of it, but I'm hoping that that will happen. Okay, so yeah, that's what I want to share. Fundamentally, the way we get value, using data, processing data to get value out of data. Previously, today, that's more of a SQL kind of thing running on CPUs. I think in the future, it's going to be more of a GPU workload. It's going to be more of an AI workload. So that is a pretty big shift. All right. So those are the three different developments I wanted to talk about. Some kind of already happened. The first two already happened. The third one is, I think, more going to happen. And if Ankur and everybody here does a great job building your products, then we can accelerate that. All right. I had a code example. I don't know if it really fits in with the flow. Ray is, again, the open source project that we're building to show how you can kind of actually make use of do this AI data processing, read data. Some of that happens on CPUs. You're tokenizing the data, computing embeddings, maybe on a GPU, running some larger GPU processing, and so forth. This is how the stuff we build fits in with some of these trends that we're talking about. Really trying to build the compute tools to power some of these AI data processing workloads. Yeah, last thing I'll share, we do an annual conference every year here in San Francisco, and these are some screenshots from this past October. We're doing it again in November, and so that'll be another opportunity where we really talk a lot more about the kind of stuff we're working on. So thank you all so much, really appreciate it, and yeah. Thank you. All right, I guess I'll hand it off to the next speaker, or are we doing questions?
No, we got some questions.
Okay, yeah.
We have some time. Anyone have any questions? Okay.
So you mentioned about synthetic data, right? And if you were going to start a startup in synthetic data, what would you have covered? And what's an untapped market in synthetic data that you would like to cover?
Yeah, great question. So like, what are the best opportunities for synthetic data? I think the most, well, the areas where it is, I think synthetic data is, so let me describe a few examples where I've seen it make a lot of sense. Coding, for sure. Coding and math are one example where you can generate a ton of really valuable synthetic data and high quality data. And this is because, in part because, you can get ground truth, right? You can generate some code and then you can try running the code. So if you hallucinated something, you can just throw it away. Or if you generate a math proof, you can actually check the proof. So if the proof doesn't work, you can throw it away. So there's a way of generating a lot of extra stuff and then filtering down to just the valid stuff. So I think that type of property makes coding and math and anything like that a really valuable, a really good target for synthetic data. I think certain biology things fall in the same category. So take drug design, right? I think a lot of companies, there's a lot of promising companies trying to do, use AI for drug discovery, and they'll have a generative model for protein sequences or for drugs that generates, millions of candidates for drugs. And then they'll take each drug candidate and they'll run a bunch of other models. They'll run an AlphaFold-like model to fold the thing and get the structure. And then they'll run other models to predict, like, is it toxic? Is it, soluble? Does it bind to the thing I want to bind to? And just like slowly filter out down to a higher and higher quality subset of data. And so there's, domains like that where you can put a lot of compute into generating high quality data. I've seen successful companies using AI for weather prediction, right? Today you have, and this applies to any domain where you have a large, like a really high quality but expensive physics simulator, right? You have, the way we predict the weather today is you run physics simulators on massive supercomputers. And it's accurate and it works, it's just like really expensive and slow. And so, but you can use that, instead of treating that as the main way to generate the predictions, you can use that as a way of generating training data. And then train a model that can do the same thing but much faster, and that's been very successful. So there are one thing about synthetic data is I think it tends to be fairly domain specific. It's not something you have. It's not obvious to me that you have like a uniform solution that will apply like across for coding and weather and just all of these things. I think you may need to think hard about the category of domains you're going after.
We have time for 2 more questions. Wow, you guys are way up there. This is gonna be a project, okay? You guys are gonna help the guy in the far back.
Great. So I love what you said about recording every single meeting. Thank you. That was amazing. I love every single thing about you were saying recording every single meeting. We don't do that with our internal team, but we do that with our clients. And yeah, you're right. We never see the videos, but I am expecting to hopefully someone will design something that will then retroactively give advice. You put the video in and it gives advice to the people that were in the meeting, like, hey, you did this, and this, and this, and this is your pattern. And that would be something that they would be learning and reinforcing how they're delivering the professionalism in the meetings. But then my question specifically on the event, is that free or is it not free? What are the details for the event?
Oh, this event is not free. We do end up charging for this event, and it is like an in-person event here in San Francisco. But we also do a lot of free meetups and other things like that. Yeah, if you're local, we do a lot of local events in San Francisco. Yeah, thank you.
Quick question, maybe more technical. You presented supervised learning, unsupervised learning, reinforcement learning. What's the next step?
Oh man. Well, I think there are. So what's the next step? There are a lot of important directions to go in with AI research, and you could, I don't know if there are just a few, but 2 of the directions that I think are most important for how do we get smarter models, or for how do we get smarter models, I think perhaps one of the most important questions is broadly, how do we use more compute to get higher quality data, right? And how do we use AI to get higher quality data? So that includes synthetic data, I think you have I think that one trend we've seen in, right now you hear people talk about pre-training and post-training, and pre-training is like this big step, and post-training sometimes is this like, you think of fine-tuning or some like lighter weight thing. What we've seen with post-training is that it's becoming bigger and bigger and bigger in terms of like the importance and how expensive it is. And I saw a nice quote the other day saying that people are going to drop the post. It's just going to be pre-training and training. And from talking with companies doing this post-training, a lot of what it looks like is alternating between improving your model, like training your model, then using your model to help generate better data, then taking that and like training your model more, and then using it to generate more data. So this alternating training inference sort of thing. So it's I think there's a lot of sort of work to do on really improving the methodology there for how we do post-training. That's very important. So that's like more on the research side. On the product and research side of more related for businesses, I think one of the most important questions is just like, how do I use AI to get insights from my data? Like very broadly, what is that? And at the end of the day, that's like a product, but it's also like there are research questions there.
Awesome. Let's give it up for Robert one more time.
Thank you so much.